equation there. It identifies our center mass of the triangle. And, okay, this is going to be a little bit, I'm going to take 20 seconds just to kind of get it all set up. So I'll take this off, and I've got the triangles over here. Whoa. Okay, hopefully that's pretty good. Where's my hand? Over here. Okay, that's over here. I'm going to just get the thing. So you have to experimentally show for the second one. Show and discuss your mathematical reasoning. So obviously I've just done that. And for this part B, you have to do the center mass of the sheet. So I've got my little thing up here. This is a bugle. You probably don't know. It's just a screw for timbered construction. And I've got a little needle here that pierces the cardboard. If you can see that there. To show you that I found the center mass of the right angle sheet of 90 mil and 180 mil. So that's a 1 and 2 unit triangle. And if I go right in the center of the thing, I don't know if you can see it there. I think you can. I don't know. The phone's to the, I can't see the screen very well. That's the 9, so it's the 9 centimeter. That's the 18. And over here, I've got the 6 centimeter, which is the 2/3 of a unit, both from the this point, because that's the 0, the origin on the graph, on the diagram, and 2/3 up this way, which is the y component. And if I put, I don't need the bugle right now, but if I put the pin right in the center, and I hold it up from the bugle, you pretty much, it's not going anywhere. And I put different holes in the other sheet just to see how much of a difference in that plane 2 mil makes, anyway. So that's it there, it's pretty much level. And I made 2 more, which is halfway in between each axis. So this is the same 2/3 along the y, along the x, but a third along the y axis, just to show you how much difference in that plane it makes. Look at that. So it does make quite a lot of difference. And I won't even show you the x. Oh no, I'll show you the x. Because this x difference in the same y component, this is the experimental way of showing them. So that's it off there. Okay, let me just quickly move this light just so you can see it properly. I'll read the next question while I do that. So, in preparation for the online replacement laboratories, which I hope go smoothly, using cardboard, plastic, or paper, I went with cardboard because it's a little bit more rigid, so it's not going to flop everywhere. Build a model that demonstrates the center mass of such a right angle triangle thin sheet, which I just did with the one I worked out from earlier. Then furthermore, consider an irregular triangle without a right angle, which this is it here. Let me just get a right angle. This is the post-it. Hopefully this shows it well. So that's obviously not a right angle. There. See the extra angle. Consider an irregular triangle without a right angle and demonstrate experimentally how the center of mass can be determined. So for this, I looked how to do this up online, and it makes a lot more sense now because I struggled for about a little bit just trying to figure it out. So first off, you have to put the pin at the very top in the center. Make sure it's free hanging. So obviously it rotates very, very easily. I made that hole a little bit bigger than it needs to be to put the pin in. So now that's swinging freely. We pull this, put this bugle down, and we let it hang. I was gonna stop the swing for a bit. So you can see it hang like that, and all you have to do to kind of, my elbow is not very stable. I'm just gonna put it on the table. So for now, it's not swinging, and you kind of lift it up, and then you take the position there, which I've already done for every single axis. So I've lined it out. You can probably see the holes in the center there. So if I do it for a different axis, so obviously you have to mark the bottom and then come back up and then put all the lines on and then do the intercept from the lines. So that's the, I hope this shows up properly. That's the other corner, and then you just pull the line down and make a mark. And then I won't show you the other one. You probably have 100 of these videos to watch. But so now that I've shown you how you do it from each corner, I'm going to put the pin in the center where all those lines intersected. So I'm just going to do it like this. Hold it from the bugle. And it's fairly good. Like it's pretty horizontal, but just to show you how much it moves, just such a small amount of error, I'm gonna show that like this. And you can hopefully see the 4 dots in the middle, and this middle dot right here, that's where all the lines meet, but all around them there's what, 2 to 3 mil of difference between those center dots to each one of the supplementary dots, I guess you could say. And if I put this dot, the pin, in one of the other dots, this is the dot just to the right, if you're looking at the longer side of the base, see how much more that comes around. So very little amount of error makes a massive difference when you're doing it in terms of center mass. And there's another one, so you can see that's a fair bit. I'll just stabilize a little bit. That's a fair bit off as well. So yeah, that's the experimental part done. So I hope this shows you what went into this bonus mark. Okay, goodbye.